Let's start working on part C now. So suppose that effort is not verifiable, but only the output. When workers decide to work together, they share the joint output equally. What's the effort, income, and utility if they work together? Under what conditions will they do so? So what matters here? It's very similar to part B, but there's one thing. The effort is not verifiable, meaning that the workers cannot agree on the effort level beforehand. So if they cannot agree on the effort level beforehand, they cannot maximize the utility function by taking into account the team production and the cost of effort of the other guy, meaning that they will basically maximize utility as if they work individually, but they do know that they will share the output equally. So there will be some level of free riding here, because if the guy knows that the co-worker cannot see how much work he puts in, he's letting some of his work to be done by the other guy. And the other guy thinks the same way. Since no one is checking him whether he works hard or not, he is relying on his co-worker to put some of that effort. So there is some level of free riding going on here. Let's see what the utility function would look like. We will have the following. We will have the utility of one guy, so let's call that U1, which is going to be his wage, and we know that his income is going to be half of the output that they produce. That's going to be 1/2 times the price times the quantity that they produce as a team. And we know that the quantity that they produce as a team is beta times E1 plus E2. And now we only care about, this guy, right? The guy cares about himself only, so he'll take into account just his cost of effort. 1/2 theta E1 to the power of 2. Let's work the math here and see what we get as a result. We have E1, right, the effort level in the first term. We have it in the second term as a quadratic term. So we'll differentiate the utility of this guy with respect to his effort level and make that equal to 0. Let's see how the math works out. In the first term, the derivative would be what? Would be just the constants. 1/2 p times beta. So we write 1/2 p times beta minus, and in the second term, when we differentiate with respect to E1, we're left with 1/2 theta times E1 squared. Derivative with respect to E1 is just 2 times E1 equals to 0. We can cancel out some stuff over here. So 2 and 2 go away. 2 and 2 go away, meaning that 1/2 times p times beta is equal to theta times E1. So we take it on the other side. We take it on the other side like that. This one goes there. So we have theta times E1. Let's divide both sides by theta to find out the effort level. So the effort level of the first guy, E1, which is going to be the same as the effort of the second guy because the functions are symmetrical, is equal to 1/2 p times beta divided by theta. Now let's compare this to the previous case, to part B, because in part B they were also working as a team, but they were actually agreeing on the effort level. They were basically making a pact that no one is going to free ride, right? They said, we are working the same way. Over here this is not the case, and let's see how that over here to the left. So let's see how that shows into the results. What is the intuition behind the numbers, because this is all some intuition behind it. Somewhere over here it was, where was it? Yes, so this was the effort level. It was p times beta over theta. We had that team effect, right? And we have p over theta, but notice now we have the same function multiplied with a half, and multiplied with a half, it means that the result is lower. Where was it? Somewhere here. Yes, the result is lower by a half, right? We only have a half of what we had before. Why is that? Why do we put less effort? Because of this sort of free riding. We are relying on the other guy. We are relying on someone else, on the co-worker, to do some of our work. That's why at the end of the day we put less work than if we would agree to put in the same levels. Hope this makes intuitive sense. So we got the effort level. What we also need to know, what we also want to know, is the income level, right? We want to know the income level, and we know that the income level is going to be half of the production. So let's calculate the total production. Let's calculate our Q. That's going to be the price times, it's going to be the price times beta times the effort levels of the guys, and that's this effort level multiplied by 2, because the effort levels are symmetrical, p beta over theta. That's for one guy, and we have 2 workers, so we multiply that by 2 times 2. Now let's work out the math over here to see what the total income is. 2 and 2 cancels out. P times beta multiplied with p times beta is going to be p squared beta squared divided by theta. That's the total income, and now we want to know the wage, and the wage is going to be just half of it, right? That's the income per person. So all of this divided by 2 is going to give us the wage. So the wage of the first guy, is equal to the wage of the second guy, which is going to be p squared beta squared over 2 theta. Or we could say 1 over 2 times p squared beta squared divided by theta. Again, let's compare this wage with the wage when they were agreeing on the effort level. There's going to be a difference based on the same logic. So the wage used to be, where was it? In part B, the wage of one guy used to be this one, p squared beta squared over theta. This used to be the wage. And now notice that we have the same term multiplied with a half. So the wage now is p squared beta squared over theta times 1 over 2 over here. Notice, again, the wage is reduced by a half. Why is that? Because of the same argument we gave before. They rely a bit on each other, they put less effort. As a result, they produce less. As a result, they sell less. As a result, they have less money. Now, let's stop here. Next video, we find utilities and conditions of working together as a team.